Yeah, you guys can mute all of you. Thank you very much. So now we'll start the second part of our discussion on the Cybersecurity Operations Center and its journey in last 2 decades up to the Cyber Fusion Centers. And in this part of the discussion, we are going to discuss 4 different generations of the SOC, which we have seen as an industry. And before I start that, I will just do a recap of one of the slides, which we are going to do, which we have seen in the last session, absolutely in the last of the previous session. So now let's look at what exactly in the Security Operations Center, how does it look like, what all people are supposed to do. So let's look from this slide point of view that there are 4 important delivery components. One, we are supposed to do something operationally, like on a day-to-day basis, operations wise. And then in the day-to-day operations also come the monitoring function, like, what we are supposed to monitor, how we are going to monitor it. Then, because there are different level of people, as we have discussed in our previous session, that there is tier 1 engineers, tier 2 engineers, and then tier 3 engineers. So all of these have to collaborate together to work in tandem, and for that they need to have some kind of a set workflow amongst them. Also, there has to be a operational and performance efficiency management, and that is delivered by virtue of consistent reports that how we have handled in our previous month, previous week, previous day, and then obviously correlating it to our performance on how do we keep on enhancing our performance in time to come. So these are the 4 key ways in which the SOC deliverables from SOC team are expected. So let's look from an operations point of view. The operator's interface, the place where the SOC operations team is going to interact with the tools and processes put together, that infrastructure has to have some kind of a dashboard where the incident and threats which are seen in the entire large infrastructure and have been consolidated, aggregated, and correlated in the SIM, the output of that can be driven on a real-time basis onto my dashboard, on my desktop or my laptop, etc. Then the incident alerting should be dependent on the severity of the incident and the role which I as a SOC operator am delivering. So if I am a level 1 operator, I should be seeing all those alerts based on the level 1 text. Similarly, the severity, as we were discussing, some numbers like SIM might give to each event depending upon the impact that event might have or the scale that event can go up to. So all that will define its severity. Based on its severity or on the basis of my role, I should be able to create filters on my dashboard and should be able to see those right screens as per my role. Then I should be able to tag the events so that they can be a part of the flow of work. So I would need mail, chat, and a portal access to interact with the infrastructure. Last but not the least, that I should be able to generate some custom reports. I don't know why there is no noise. And for monitoring of events, we are expected to write that the team which is responsible for the security operations, there have to be right set of people who should be writing the correlation rules, or who should be activating the existing correlation rules that have been supplied by the vendor whose SIM tool has been procured. And these correlation rules should be able to connect the dots between the events. Humanly, it is very difficult for any human being to keep track of 5,000 or 500 users logging in, who is logging at what time, and how is they are operating when they are working and giving the passwords. And then the example which we says that, okay, after 5 wrong passwords for a user, if a successful password comes within a window of let's say 30 minutes, that would mean that there is a possibility of it being a brute force attack. And to arrive at this kind of a correlation end state to declare it to be an attack, we need to have a correlation rule that has been written to identify this, which otherwise is humanly not possible, for reading for let's say 500 users or 5,000 users network. Then to do a effective and efficient security monitoring, the data normalization has to happen, aggregation has to happen, which we have already understood. And also for effective visualization, we need the right graphs, different color combinations to represent different severity and the roles level, so that the visually the events can be differentiated even if I am looking at the screen from a far distance. So this all is going to give efficiency and effectiveness to events monitoring. So that's why the security operations team in their delivery framework has to keep track of bringing this into a very important requirement. Then the workflow, because multiple people are working, and we all know that any organization which has 24/7 monitoring teams, all people will not have similar experience and exposure. Second, that there will be multiple people handling a similar event or a ticket. So in that scenario, there has to be an appropriate workflow that has to be aligned to the processes, which means if the issue is not handled or responded by a level 1 engineer within 30 minutes or 15 minutes, if its severity is high, it should automatically get escalated for handling to level 2 engineer, because here we are talking not about troubleshooting but the real security events management. And any miss of the time window might lead to a catastrophe at the attack level. Then these workflow systems have to be tightly integrated with the CRM tools that basically helps the customer to be able to see the progress of the issues. Here, if the SOC is in-house of the organization, like a bank or a telecom, then to them the customers refer to the ones who are going to be the other IT and security and network teams. However, if the organization is small and they have outsourced their SOC business to somebody else, a third party like QoS technology, then in such scenario, the CRM tools help the customer to be able to interact and see the progress of their respective issues. Then also we know that if the graphs and views are there, it's sometimes humanly difficult for anybody to have an attention span for 8 hours of duty on the desktop or on the screen. So therefore these graphs and views have to be substantiated with the mail triggers or with the Android/iOS apps, so that the users who are having a cup of tea or having a break time, not looking at the screen, while they are responsible for the level 1, level 2 operations, they should be able to get a trigger on their interfaces like Android app, iOS app, or on their mails for any critical events if it strikes during that window of break, etc. So therefore, these additional mechanisms for workflow seamless integration are expected. Last but not the least, in the workflow, sometimes for the security operations team, what happens is that the level 1, level 2, level 3 engineers who are responsible for SOC, they might need sometimes a very specialized help from the subject matter experts. So for example, if they are dealing with the customer where they are seeing currently some kind of a DDoS attack happening right now live, they may not be very great experienced on DDoS protection and anti-DDoS tools. So they might take the help of anti-DDoS expert, which might be present either in the same office or in the different geographical office for the same company to get the help of. So therefore, every such organization has the subject matter experts for different security technologies and the recognition and triage of different security threats. Therefore, they will set up the shared services infrastructure to whom this SOC team might have a workflow based access. So they will engage level 2 subject matter experts as a offshoot of their requirement process flow, should they need any such expertise on the fly or in solving any incident. So all this comes under the objective of alerting and automation. Currently, looking from whatever we have come to know about the SOC. Then there are operations report. We all understand that reports always helps us doing a historical analysis. And with long-term, short-term historical analysis, we come to know that where are we, what are we doing, how efficiently we are solving problems. And if we see some spikes of underperformance or overperformance by a month, by a daily report or a weekly report instead of a monthly report, with this short-term analysis, we are able to understand what is that what we are doing good should be then further escalated to make this short-term trend a long-term trend. Or if we start to see a dip in our performance, with this short-term report, we come to know that yes, maybe we have stopped doing this, or this is something which has happened, which has led to our changing patterns of efficiency. So all these reports, therefore, are very critical and important for the historical as well as real-time analysis of our data. Lastly, for security operations center efficiency, there are many third-party tools which are beyond SIEM and beyond the vulnerability assessment tools that we have seen so far. These are typically called as crystal reports, etc., on which or similar such reports. So you can actually see those efficient models of SOC, and they will compare it with the desired objectives, how you have to be seen as opposed to what you are actually delivering. So that gives you the benchmarks, that gives you the journey of how you are expected to deliver better. So all this comes as a part of a security operations center scope of work when we are setting up this together. And if you see that, it will be delivered by virtue of three important pillars, that is people, processes, and tools. Now let's see how all this, what we are talking about at the SOC deliverables, how did it start? What all we were delivering and getting in each of those generation of security operations center that we have seen in last 2 decades. And in that generation, what was a key focused approach? Also, we are going to see it, the third thing, which is basically the challenge that was realized in that era or in that generation, and that has been solved maybe in the subsequent or subsequent to the next generation of deployment and deliverables. So starting with what we are or how we started. So let's talk firstly, what was a primitive SOC? When the SOC word was not born, you know, what people were doing before that, and how did it actually, uh, how somebody conceived that they just need to do security operations center also. So if you go back to 1997, 98, maybe early 1999, you would understand that in the primitive SOC, what was happening was that the objective was to monitor the availability and performance of the security devices that were deployed, like checkpoint gateway firewall or a Cisco Pix firewall or antivirus from Trend Micro or antivirus from Symantec or Dr. Norton. So those were the two important technologies that were happening in the cybersecurity space way back in 97, 98. And the first things which were expected for them to be part of the operations center was to actually understand if they are available and how are they performing. So that is what exactly started to happen as the first thing. And we used to see that when we were deploying these security gateways of Checkpoint or PIGs, people are expecting that they should have some kind of an SNMP, okay, simple network management protocol based traps, which means if something has gone wrong on a firewall or it has stopped processing the data on the network interface card, or its network cable has gone bad, whatever might be the case, or its fan has stopped working, or it's heating beyond the required threshold of temperature, all those traps should be sent to some centralized management framework. Mind you, we were still not talking about the security events. Nobody in 97, 98, 99 was asking that, okay, what if the firewall has seen a IP scan? What if the firewall has seen somebody who is trying to understand which are the TCP ports that are opened on my web server? So nobody was talking about that. It was only the availability of these security devices which was there. All of you who are seeing SNMP word being used for the first time in front of them, they are supposed to read about this on the Google. And all I want to tell you is that SNMP happens like monitor the CPU temperature, monitor the memory utilization, monitor the number of packets the network card is receiving. All this, what a machine is supposed to monitor and report to SNMP, that monitoring database is called as MIB. Okay. So there were MIB1, MIB2, and so on and so forth. So you are supposed to read this if you are seeing it for the first time. And all of you who have an experience of SNMP, I am moving forward. The approach was using these MIBs, configure the important attributes of SNMP, which we wanted from cybersecurity tools. And we used to expect that, okay, if something will go up and down on this attribute, beyond a threshold or beyond a value which is acceptable, we will be monitored on a centralized dashboard of SNMP manager. And then we started to realize that for example, a vendor A's firewall is supporting only MIB1, while the requirement on the SNMP server today is MIB2, which means they are living in an older generation of MIB. Secondly, we started to feel that not everybody was supporting SNMP. So these were some challenges which were faced. But since it was not a security operations, but a performance and a capacity readiness of a security devices which was initially being managed and monitored, but it gave the birth to something called as the Generation 1 Security Operations Center. In the Generation 1 Security Operations Center, the focus was moved from beyond the SNMP/device availability objective. For the first time, we started to talk that, okay, which are those security events that are of importance from a firewall and an antivirus. And by the time generation 2 started, two more tools were introduced and were getting deployed in the companies. One was IDS, that is intrusion detection system, beyond firewall and an antivirus, I mean. And the fourth was that people have started to adopt the URL filtering solution. So they were wanting that the organizations who have deployed the internet in their organization, people should not be wasting their time inside their office to go to the unsolicited news and information / learning sites. This is era between 1999 to 2003, 4 I'm talking about. So in that scenario, people have started to understand that now there are 4 or 5 important cybersecurity tools, and each one of them are generating logs. And in the event of any security issue, some engineer has to understand these 4 different types of logs, and then they have to connect on the timestamp basis that how are these log entries from one coming from a firewall, another coming from an IDS, and a third coming from an antivirus. How are they correlated? How are they linked to each other? Are they part of a same attack or a event, or they are independently atomic events? So this was a place where the consolidation of log was started getting to build as an expectation. Second, by the time these security tools were deployed, organizations like payment card industry, etc., they started moving the physical transactions to electronic transactions. So, we have seen the proliferation of currency moving from a bank branch exchange model to a ATM model in the similar time between 1998 to 2003. So that is the time when the ATMs on the banking side proliferation happened. That is the time when the telecom infrastructure was moving from a typical X25 frame relay formats to a IP based interactions. So when this was happening around us, the organizations which are controlling the industry like banking, telecom, and also in the health sector, not in India but in the Western world, the records of health have a very important consideration. When these systems started to move on to the IP infrastructure, the compliance bodies started to see the patterns which, or the compliance needs which were applicable for the physical records, started getting to build for the logical or the electronic records. So banks, they maintain their ledgers for years and years. So similar way, they started to push that in the electronic event, maybe 1 year, 3 year is the log retention time when they would need. That if suppose any investigation happens, they would need a fraud to be tracked as old as what has happened 2 years ago or 3 years ago, because some frauds in the bank used to span across this level of time window. So therefore, they started to come with a very strong requirements, because these firewalls, these antiviruses, these IDS, they were seeing those security logs or events. So they were expected to align themselves with the regulatory compliance requirements. So that was also very key objective which came into being. Then the companies like NetIQ, EIQ, ECOP, they just came into being. Today they are either acquired by some other organization, or they do not exist, or they have evolved themselves from just a generation 1 to a current generation of company. But these names just came way back in 98, 99. And what they started to do was that they were centralizing the log collection from a firewall, from an IDS, from an antivirus, and from a URL filtering, and was starting to bring at one single place. But the output which they were giving was only a console, which will alert the moment it will see some heuristically different event, which means when it will see something which is not, somebody is trying to generate too many logs on the firewall from one single IP. That was the only level of intelligence which was coming in. But this was delivered with series of challenges. Number one, it was only a log consolidator in the generation one. It was consolidating, which means it was bringing the data from multiple sources as was trying to give it into some form of single window. So instead of normalizations, it was dependent on the 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 SDKs, software development kits, which means maybe NetIQ will be great to integrate with Checkpoint, but it would not be great to integrate Pix until they write a connector. And then another problem they started to see was that if Pix, when it got acquired by Cisco, Cisco used the same version. But the moment Cisco started to work on it, it came with a different version. So when this happened, it started to give a challenge that, okay, the same log consolidator, which was working with the previous Pix, the moment somebody has upgraded the Pix version, it's no more working. Pix was the first firewall which Cisco started putting into the market. Okay, and it was one of the very powerful firewalls after particularly Checkpoint. So this started to become a big issue. And also because they were not doing a great normalization and great aggregation, so their log retention needs, or the requirement of a magnetic tapes and the SAN storage, they were like growing like crazy, so people were maintaining those logs because they were driven by a requirement of a log as long as 2 years 3 years log retention. Therefore this all was like a mammoth expectation from a solution. But that's where the industry was moving very fast. So we did not see too many years in generation one. It was just like it came as an interim because somebody was building something bigger on the top of it. So it stayed for 1.5 years, which means all these companies were only having a solution of log consolidator. That time was only about 1.5 years. By the time year 2000 ended and 2001, the dawn of 2001 brought the very interesting solutions for cybersecurity operations center. And that is when the first time we started to build the value around security operations centers. So in 2001 onwards, there was an absolute explosion of SOC. And when we set up our first security operations center for the company I was working in the year 2001, we were setting up in one of the names that I am showing you here: Net Forensics, ArcSight, RSA Envision, Novel Sentinel, Cisco Mars. So these are the solutions which were launched in the era from 2001 until almost 2004-5. So these new company tools, they started to come into the market. And as first few engineers on the security operations center, I'm telling you, these are very, very amazing tools of their own time. Some of them are very, very popular till today. If you pick up those names, they might have changed their names. They might have moved from one OEM to another, got acquired by one and moved to another, and then got further acquired. Or after their third acquisition, they have been rendered back again into an independent entity. RSA is a wonderful example. It got acquired by EMC. EMC was acquired by Dell. And now Dell, after having some romance along with RSA for many years, they are now carving out it as a separate company. But they have been an amazing, they have an amazing run with the cyber security. And so is with ArcSight. ArcSight was an independent company, an amazing SIM company, got acquired by HP. Then it got segregated into Micro Focus, and then further, Micro Focus has actually rendered it as an independent entity under some private equity company. So all this is happening. However, the tool remains the talk of the town. They are very, very popular. So in 2001, what they did amazing was that they brought a regular expression and a vulnerability based correlation engine. That is what actually has created a landmark, because somebody, without the need of human being to connect the dots between the log which they are seeing it from the router, to the log which they are seeing on the firewall, to the log they are seeing on the IDS, to the log they are seeing on Windows machine / Linux machine, to the log they are seeing on the antivirus installed on that Windows / Linux machine. Imagine these 5 different elements generating 5 different types of logs, and these 5 different types of log for a single event which a hacker has launched against something running on this Windows machine, have picked up atomic information of their own type, what they could see from that event. Sometimes all 5 will record something suspicious. Sometimes all 5 may miss entire event as a whole, but sometimes 2 out of 5 will pick up something suspicious. So whenever we have multiple, more than one person seeing something suspicious, it always have a possibility of connecting a dot. It always have a possibility of understanding that this could eventually convert itself or evolve itself to a event of attacking nature. So all this came into being by introducing a rule-based engine. And what these vendors, these names, not only what they did was that they did not leave the writing of the rule only on to the security operations team of that enterprise company which is investing into this tool. They also started giving the potential attacks which their research team are seeing, or the worldwide advisories are getting issued. They started translating that advisory patterns into the correlation rules, and they started pushing these correlation rules as the readily available signatures into the tool. So that's how the objective was put up and the approach was set up. SIMs of generation 3 were very, very, very popular from year 2001 till 2014 or 13, I would say. Until that year, all SIMs have had an amazing run. They were one of the very, very successful security solution deployed in the respective ecosystem. Only in year 2013-14, when the attacks became very, very complex, the biggest problem which these tools were having started to take the surface. It started to get exposed. What was that? Read that line, which I have written here. Alert only dashboards with action dependency on the people. This is very, very important. From their inception into the industry, both generation 1 and generation 2, including the primitive SOC, everybody was giving only alerts, which means alerts will lead or will wait for an action to be taken by a human being by virtue of a well-defined process. Imagine, that is the expectation. So what had started to happen between 2011 to 13-14 is that post-Stuxnet era, the attack vectors have become compounded and they have become more than a single atomic attack vector linked by multivariate attack function, which means it might start with an exploit and will become an absolute data exfiltration event in the end, which is called as a cyber kill chain. You guys can read that separately if you are hearing it for the first time from my side. So all that has led to the issue that alert only approach cannot be sufficient, because it requires a lot of skills now in the underwriting function of writing those rules, because these are complex patterns, and Imagine when a atomic nature of an attack gets compounded, and then compounding also is substantiated or amplified by multivariance as well as polymorphism. We have discussed these. Polymorphism means when one thing exists into multiple vector formats. And a metamorphism means when one evolves from one type of attack to another type of attack. And if you mix all this together, imagine the permutation and combinations for a single payload or a single exploit that are possible today. So that has actually made it very, very difficult for the level of the skill available at that time to recognize these patterns and keep on putting into the correlation rules. And if they were doing so, they were actually landing into thousands of alerts every day. The second thing which has started to happen in 2013-14 was that we as an organization have adopted a different form factors of interacting with the compute. There was a proliferation of tablets, there was a proliferation of smartphones, there was an introduction of something called as the wallets, which are requiring API, that is application programming interface based communications from different. There was a cloud introduction. Also in the industry, we saw that there is so much of social networking which is becoming popular and part and parcel of the marketing teams of no matter what kind of business you are in. And all these social expressions are not the structured data. So there's so much of unstructured data, a video, a social sentiment, a emoji, all these are unstructured expressions. And all they have, but they carry a lot of information. So these needs of log sources to be structurally available, coming from a firewall, from a router, either in a syslog or a netflow or a packet data, was no more sufficient. It needed larger now spectrum of devices in the telemetry to be expected, to be part of the security issue, which might happen at any one of those form factors. Hence, this all has led to a situation where for many years between 2000 to 2013 to 15, many attacks started to getting missed from under the nose of SIEM. That it happened so that in 2015 RSA conference, the chief data scientists of Verizon, they exposed that the last year events or the breaches which they have seen as a company. Verizon happens to be one of the largest stock company, okay, globally. So they published a report that not even 1% of those breaches have been prevented by virtue of SIEM, and that gave a very, very big shock to this entire SOC as a whole. And then the good part was that the organizations like Mitre, they came to the rescue and they launched the cyber resilience engineering framework, which gave a birth to something new to be thought through in the generation 3 SOC. And now in 2018-19, again, Mitre has launched another framework which has actually became a foundation for generation 4 SOC. So now let's get into what is there in generation 2, generation 3 and generation 4 SOC. But before that, before I start that, I would like to take few questions, because generation 3 and generation 4 SOC, again, generation 3 came for a very short duration. It was a need of the hour between 2015 when this report was published by Verizon, and it has actually created a big jolt for the entire industry across the globe. So there were knee-jerk reactions, and as a consequence of that, there was a generation 3 SOC. but more or less, it has transformed itself to a much matured model of generation 4 SOC. So virtually generation 3 and 4, we are going to see it as a common theme going forward when we are getting into a part 3 session. But I would like to take some questions in case we have so far, whatever we have discussed. So I'll break it open for 5 minutes for any questions. Yeah, you guys can put it in the chat window if you would want. Any one of you, are you hearing me? Can you just say that?
Yeah, we can hear you.
Great. Or you guys can tell that, yeah, this is good enough. We can just move on to the next. So I'm okay.
Sir, according to me, it is good enough. I think we can move on.
Who was this?
Amit, sir.
Amit Rao.
Yes, sir.
Your answer is negated, Amit Rao. So other folks. Amit is a champion.
Like we have more questions in generation 3 and 4, sir.
You have more questions in generation 3 and 4. Okay, good. Okay. Anyone else still want to attempt a question? Okay, good. Thank you. So now let's start with the generation 3. In generation 3, the biggest thing which that Verizon report has actually brought on the table was that SIEM does a great job of alerting, which means it works for time to detect. It helps you detect. But response function is also a function of time. And if we don't respond well, or we don't respond on time, in either case, the attack is going to be successful. So what do we need? We need to have some form of triage, which means choices in the response. Instead of just letting it happen and leave it on the people and processes to take it alone, we need to inform not only the human beings, and then they will use some process to act, rather inform the machines directly. The machines who are going to act, and that function is called as automation. Another important thing which happens, let me tell you, I'll bring a very important political angle which exists. Unfortunately, it exists across the organizations, across the geographies. And the political angle is that if you look at the organization inside the customer, you will have a separate network team and separate security team on most occasions. Then there is a likelihood that you might have a separate servers team. And today, in the complex large organizations, you might even see that within the server teams, there are two different teams: the compute team and the applications team. The team which is going to handle the compute part, who will be working with the VMware, working with the Intel, Nutanix, all those guys who are going to put the infrastructure on place. And then there are people who are working with the application stacks, like what is going to be done in GitHub, how is going to put it into Dockers, how is going to be done with various other frameworks that we are going to use it on Azure, on AWS, etc. So these complexities, and we all know that in such architectures where the power is distributed or where the decision making is distributed, it is difficult to achieve a common unified goal. Hence, because the administrator of VMware is different than the administrator of Microsoft running on that probably the administrator of Cisco ACI, which is, or a Cisco switch, which is right now underlying as a device, is different than the administrator of checkpoint firewall. So all this is different set of people with the different egos, with the different objectives, with the different goals. This gives a very big problem in expecting and allowing automation to happen. So everybody will not very easily that, okay, a security guy who is handling a security operations will take a decision, okay, go and block this URL, and then that URL will stop my Amazon access for the GitHub. This will not be easily acceptable because multiple teams are involved in this. So what is required? That this particular way of response is not fully acceptable to everybody. Then let's have an orchestration. Orchestration is one level lower than the automation. In automation, we create a closed loop, which means machine tells the other machine what is required to be done without letting the human beings to come in between. It's like a feedback loop which works for the corresponding or a subsequent action. A subsequent action will give a response, and then the basis of that response, the action will be further taken to take the control or to next level. So this is an automation closed loop environment. But in the orchestration, what happens is that I will, as a security team, define the corresponding action which a VMware team or a Azure team or a Cisco team or a Juniper team or a checkpoint security controls team or a device management team is supposed to take. I will orchestrate, as a security operations team, I will orchestrate an action for them as a consequence of the attack which we are seeing. I will not just simply leave it at the alert level and let the people to decide and interpret in their own way. So therefore, automation and orchestration is getting built as a part of more collaborative possibilities that can cut across multiple vertical teams. So you would see that the organizations who have seamless integration between the teams, who have much collaborated environment and less politics or bureaucracy between the teams, they are maturing the generation 3 SOC. And in doing so, they would need additional tools to deliver this. So there are two parts which are required. One, your SIEM has to be smarter than just the correlation rule. And that smartness in the correlation rules is called as a security analytics function, which means it has to go beyond just the predefined correlation rules. It has to dynamically learn from the heap of data, connect the dots inside that heap of data, and start giving some dynamic anomalies rather than just the triggered or the fired correlation rules output. So that is what brings the SIEM to a next generation SIEM. And that next generation capability of SIEM is delivered by virtue of augmenting the regular expressions by something in the form of a machine learning / artificial intelligence. That's why you would see that from the year 2013 onwards, the different companies have started to lead the market of SIEM. It's no more net forensics, it's no more RSA alone, it's no more the Novell, Sentinel or Symantec, etc. It is the new names, Splunk, Logarithm, and IBM acquiring or bringing a artificial intelligence based modeling into their existing or previously used tools for SIEM. RSA acquiring multiple companies to bring it under their umbrella of SOC tools which they used to have previously. So virtually either those existing companies of year 2001 onwards who are sustaining till today, they have evolved their SIEM capability to include that smart function of automatically bringing the analytics along with just the regular expressions. That is one thing which has happened in the SIM, and also the action has been added on to that. So what is the reason for doing that in the SIM itself was because if I am proposing as a SOC team for my VMware guys or my networking team guys or my security device management team guys to take some action, I need to be having completed the entire analytics beyond just the regular expressions. They expect that from me. And for doing so, I as a SIM based tool in my SOC operations have to have that analytics capability. So this analytics capability is a very common term called as big data security analytics. Okay, so virtually Splunk, logarithm, etc. are no more just the SIMs. They are SIM plus big data security analytics. So they are all of everything inside one single box. When we do that in their SIM solutions, apart from that, they would need that whatever intelligence they have built locally by virtue of the events which they are collecting, and that intelligence is defined in the form of some kind of critical index values, let's say 4, 5, 10, 7. We all know that 10 is higher than 7, 7 is higher than 4. So all those numbers based modeling or any other model of low, medium, high, critical buckets, no matter whatever it is, in whichever way they have classified those events as, they need to be substantiated further by automation as well as orchestration. So this was referred to as SIEM plus SOAR journey. SOAR stands for Security Orchestration and Automated Response. So start looking at the SIM in generation 3 that most of the SIMs have to have an inert or inherent or out of the box capability of machine learning / artificial intelligence based threat modeling, which means they will be beyond just the correlation rules which we have seen in our previous session. Definitely correlation rules will be there, but something more smarter has to be there. So if we see today and draw an analogy between antivirus of the past and what is antivirus today, today's antiviruses are not just dependent upon signature. They need signature plus a dynamic code analysis, which is by virtue of some kind of machine learning. Every OEM who is giving an endpoint security agent is using the static techniques as well as dynamic techniques to interpret. Static techniques are like a correlation rule, and dynamic techniques are the ones which will be dynamically interpreted from the real-time data. So all this is a part of the SIM today, and SOAR is a platform which basically will pick up the inputs from SIEM as a starting point, and then it will either, based on the way it will be configured, it will directly reconfigure the security devices, and that will be automation, or it will drop a rule, a new signature, a new configuration attribute that is required either on a firewall or an IPS or in the URL filtering engine, or an antivirus, or in the code of or the directory of DNS, whatever is this, it will create that event and hand it over to the device manager of that respective tool or that respective asset, be it network, be it security device, or a system or an application. And that asset owner, once he approves that change, it will automatically reconfigure it. So that means you are planning the action either by automation or orchestration. And in this generation, as I have already told you, the biggest challenge which the industry has felt, that the team A is reluctant to allow a SOAR which is in the control of team B to change their own assets. Because I, as a security administrator, may not be comfortable in accepting a change which somebody else has suggested me. Because if that change goes wrong, I might have taken already a train from my office back to my home in Thane, and then I will figure out after having reached there, something has come up and now I have to travel back, or I have to take a remote session and my entire night will go to solve that problem. So that's one very big challenge. Also, in the SIEMs, the unsupervised learning models which are used for artificial intelligence, they are not very accurate. Why? Because for them to be accurate, there is a huge amount of data which is required for a right event versus wrong event. Now, what does it mean? Let's take an example that I'm just moving out of this discussion to give you an example of what it means that not enough data available for unsupervised learning for an accurate prevention. It means that if suppose we have to build an application that will detect the flights with the weather delay in Bangalore or in Mumbai airport, imagine. Why? Because I want to launch an insurance application which will say that if your flight delay is because of the weather, I might as well pay you 3,000 rupees for every delay of more than 2 hours. But for that, you need to buy a policy of 500 rupees along with your ticket. So that is a business model for me as an insurance company. And I go to see that Bombay is an airport which sees 2% delays throughout the year attributed to weather, because it has extreme monsoon weathers. Now, this means it's a great opportunity for me to make some millions, and then I will end up paying some $100,000 back, because that's how the insurance companies build up. To build this model very accurately, the biggest challenge I as an insurance company will see is that there are 2 million flights which touch down and take off from Mumbai airport every year. Out of 2 million flights, 97% of the flights land on time or take off on time. 3% of this 2 million becomes very small number, first of all. And then within that small number, only 2% of that is a delay. So 3% into 2% becomes actually 0.6% is the net delay. Now, when you have to find out which flight or when is that probability, it becomes very difficult with just a delay and the timing as the attributes to see the data. Because the successful data of the successful flight is so huge that it absolutely makes the other number almost zero. So 99.94 is absolutely a very big number as compared to 0.6 on that pattern. So that's how you'll have to see. So in the same way, in the heap of successful events which the SIM is seeing, the actual problematic events maybe in the entire day are not more than 100. So when they are seeing millions of events and then they're seeing just 100 potentially of threat events, it's very difficult to build the right patterns. That which are those important attributes in the feature space that I'm going to focus on, from where I will pick up that yes, this is how I'm going to build an unsupervisedly learning engine model. So that's what exactly makes the situation difficult. If I have, the way I've said, if there are 50% of the flights which are getting delayed, and in that 50% flights getting delayed, 25% of them are absolutely because of weather. That rich spectrum of data, what time, what date, which moment, what was the rain pattern, all that will then probably help me to find out. Same way, if you are seeing multiple attacks in the real bank environment, along with the real events, then only you will be able to see the right tool. But in the lab, when you are simulating it as an attack, in the lab you will simulate it with the similar patterns wherein the machine will pick up the pattern itself from that it is coming in that, and start building a unsupervisedly learning model based on that. So it's very difficult to arrive in the cybersecurity space at a great, accurate, unsupervisedly learned model in the so far data what we have seen. Yes, we are maturing ourselves, and the SIM vendors are learning it, and maybe after a few years they will be able to evolve it to the better models. So this brings into understanding that even if I give a score of 8 or 9 or 10 to take an accuracy, it might be only about 60%, 70% accurate. If it is 60-70% accurate, then the only thing which we see is that, is it better than a human being or it is worse than a human being? If it's better than a human being, people are accepting, okay, let's take some kind of an automation. Otherwise, from generation 3, only one thing which has become very, very acceptable, and that is orchestration. Automation is still lying low. Now questions before we move to generation 4. So this completes from my side the understanding on generation 3, and then we'll move on to generation 4 in the next slide. But before that, if you have any questions. Good. So we'll come to the last slide of the day, and that's generation 4 SOC. In the generation 4 SOC, yeah, I've seen somebody typing something. Let me see what it is. No, generation 3 was never able to predict a log. So we are getting into a generation 4 SOC, and in the generation 4 SOC, what we are seeing is what you are asking me, the question. So in the generation 4 SOC, the objective is now to start, instead of just focusing on the orchestration and automation as a key, the focus has been brought onto the intelligence. And in that intelligence, the fact is that how are you going to consume the intelligence as a primary function of your decision making? Not just that you are going to focus only on automation and orchestration, and then you let your SIM to have a big data analytics, and then based on that, you will do only those specific actions. And as I said that the generation 3 has actually evolved into a better solution, and that's generation 4, where the intelligence is the key function. And in the SOC, it's a composition of people and processes that is becoming a part of orchestration function. And that's called as a platform. So people and processes are being tabulated together. And instead of just saying that, okay, I will write a rule or I will write a new authentication policy, or I will write a new signature onto the antivirus by directly from SIEM based model, which was there in generation 3. Instead of that, the collaboration is what is being written in the same SOAR tools now. That, okay, we will have right checkers and makers of the problem. And we know that we'll have to comprehend this factor that there are multiple stakeholders of the technology. So the device managers for routers, device managers for switches, device managers for security devices, device managers for VMware, device managers for compute, they are all going to be separate with an assumption of that way. How we can still make a unified framework so that they collaborate in a workflow model, rather than somebody simply writing that, yes, this is a action and now you accept it. Now, for this to happen, API-based approach has become very popular now. So the platform, which is going to be a platform after your SIEM for security orchestration and automation, it is going to be capable of, it's more capable of APIs to be able to write or suggest and interact by handing over a particular action to the next element in the line. Automation and orchestration definitely is the end goal, because that's what was missing in the generation 2 SOC devices, that they were only defining an action, but there was nobody automation and orchestration. But the focus is not there. It's a part of the approach. So that's how you will see. It was no more, it was an objective in generation 3 when we launched it with some objective. And then we found that when we started talking about that objective, it was outrightly rejected. But it has its own merits. However, it cannot become an objective. It has to be part of the approach, of part of a solution. Orchestration and automation are a very, very important functions. But you cannot have that as an objective, because it was being not very easily, comfortably accepted by the teams. So that's only the difference. So certain things, what happens is sometimes it is not technology which is not good. It is sometimes the way it is presented and the way it is targeted. So in the generation 3, it was targeted that, oh, I want to achieve orchestration and automation. The moment a SOC industry or a SOC vendors have started proposing this, there was a door shut by almost everybody. But when they said, no, we are creating a platform, it's the same technical thing presented in a different way. But we are creating a platform. In that platform, the objective is absolutely to collaborate your process and people, because people and process, they actually are not very tightly locked to SIEM. And then by this, we give you an option to orchestrate and automate, because you would need to pass on the technological handshake between one team to another. And the same orchestration and automation has started to be accepted by the people. And in doing so, Mitre attack vector matrix, which is written in this way, there is an ampersand in between written. I solicit all of you guys, after this session, spend at least 2-3 days on this. So what Mitre attack has done is, Mitre attack matrix has done is, it has given a unified language to multiple vendors, to the customers, to the consumer of this information, everybody, a common language in understanding the threat vectors, in understanding the threat models, that what all is my surface of attack, and if that surface is there, what are the possibilities of that attack, and when that attack is there, that how to pick up those patterns, either by virtue of SIM or SIM substantiated with the incident response platform or SOAR platforms. So this has actually helped variety of organizations to either buy a SOAR platform and collaborate it with the way Mitra's attack matrix is suggesting, or write their own Ansible. Ansible is an open source based way to write those orchestration, but the underlying framework will be attack vectors from Mitra, the way Mitra has put it. So you do a Google search and start understanding. It's a very big library. It's like a dictionary. You will not be able to learn every word mentioned in a dictionary, but whenever you are stuck, you can go back. Whenever you are starting to see that maybe after 1 or 2 years of your continuous work on this, you all guys will start talking a common language. So that's what a framework has helped us. And when you have a framework, everybody can make an abstraction in form of a platform. And what a platform is, that if you see that one organization is very matured in their politics, that yeah, network team, your operations team in the compute, and your security administrators team, they are all separate teams, but they are very, very easily collaborating. There is no bureaucracy in them. So you will be able to make a loose platform faster. But when you see that you delivering the same requirement to a different organization, which is actually politically very charged organization, everybody is waiting for the failure of the other team, you can make your platform to take decisions rather than humans being left over for that. So that's a power of platform. It gives you flexibility. It gives you a customization to the desired framework. But when we are doing this platform versus readily available product based approach, every project for the companies like QS or similars, or for any OEMs, there are huge set of features which are available, and then somebody has to actually spend some time, because every customer is different and their needs will be different. Every organization is different. So you will be able to offer them flexibility to them. But this platformization of security operations center approach will go far. And that what is giving a birth to a generation 4 SOC is no more called as a generation 4 SOC. It is called as a cyber fusion center, CFCs. Now, having said all that, important thing, the challenges which we are still figuring out, which we have seen, because generation 4 SOC is definitely going to stay for long. One, it is yet to be DevSecOps ready, because we are seeing that all these applications, when they are moving into a DevSec or a DevSecOps, they're going to have some kind of a security frameworks inside their DevOps. The maturity at a current generation of data centers is still yet to be achieved. And then huge adoption of DevSecOps is putting a lot of pressure on the generation SOC 4 to move faster in maturing itself, so that it can accommodate and absorb DevSecOps faster. Second, the people who are required for these times in the operations team are not just the security operators. They have to understand the threat models. Typically, what we have seen is that if you will talk to anybody who has been working on the security operations centers, and their security operations center is deployed on RSA, you give them a role. They must be doing that for last 15 years, and they're great guys. The moment you put them into a security operations center, which is not RSA, but is on ARC side, they will struggle. Why? Because they have mastered the operations around the tool. So definitely what we preach and talk for last 4-5 years, that's the purple skills, which means you need to understand the blue team role, because that's your role. But you have to also understand the hacker's mindset in the form of the red team skills, and that will help the organizations in the time to come to be able to deal with the desired security operations, or the people who are already busy in the current times in the security operations role. They will have to evolve themselves to be able to understand the threat models. And Mitre attack reference model is going to be one of the very, very exciting opportunity for all of us who have been doing security operations for many, many years, to arrive at the common expectations that are getting built between the OEMs, between the customers, and the consultants and the delivery teams like us. So this brings me to the end. We still have 5-7 minutes now for the questions to be asked. So this brings me to the next session, which we are going to do tomorrow, 10:30 a.m. And this slide, any which ways you guys have seen. So I've just tried to put it again to recap everything. Yeah. So we have understood that the security controls, the network devices, and the critical systems in my company, they're going to collect the data, and that data is going to be moved or collected centrally on the SIEM. SIEM, by virtue of big data analytics, is going to give the risk scores, and these risk scores in generation 4 SOC are going to be further enriched by some third party intelligence, and we're going to learn all this tomorrow again. Okay, so we will delve each one of these again tomorrow, because we are going to build a complete generation 4 SOC from what we are seeing so far, learned based separate elements. Then comes the decision tree, and the first decision tree decides that whether, if the risk is score assigned by the SIM is above 8, then it should automate the action. And in the automation of the action, it should force that action by virtue of something called as an indicator of compromise, written on or suggested on the security device or the network device or the critical application that is participating in that user transaction. This will be achieved by Mitre's model of attack reference, and that reference uses the open source technologies to pass on this intelligence to the security devices which are doing that respective controls and actions, be it firewall, IDS, IPS, antivirus, URL filtering, or DNS, etc. All these devices will be receiving these indicators of compromise once the score is higher than 8, in the form of an Ansible connection or a Stix taxi being the protocols. So all these, we are going to discuss tomorrow much depth. But if you guys are interested, you can just do some research tonight, so that you are well versed tomorrow on these new terms which I am introducing on this slide. Then, so Stix taxi is nothing but basically Stix is a language and taxi is a protocol for communication, for intelligence. And intelligence is in the form of a URL, which a bad URL has to be written into a URL filtering, or a bad domain name, which we have understood by SIM and all this enrichment process and given a score to 8 and above, which means it's a bad domain. So that domain should be written in the domain generating algorithm protection systems, be it your DNS or be it your anti-DDoS or be it your anti-APT tool. it is a bad URL or a command and control URL, then also it will be written in the form of a bad URL, either in an antivirus engine or in a URL filtering engine. And if it's a real bad IP address where you not want your organization to interact with, you might as well give it on the router or on the firewall to the access control list. And in doing so, this information which is bringing what an action to be taken is in the form of stakes, language, and the protocol which will be used to move the intelligence from a platform which we have talked about, the SOC platform or a SOAR platform, towards the security control where this new information will be ingested and applied, is basically using a taxi protocol. If the risk score is lower than 8, then move to the next decision tree. Is the risk score higher than the 5? If it is higher than 5, then enable your human beings to do a hunting role. Hunting means find out more information about the event. Find out more if some people around the world are facing a similar threat. Are they seeing the similar symptoms? So that by hunting that information, you are able to arrive at a conclusion whether to generate an IOC, which is an indicator of compromise, and then applying that back to the same way in which the Sixton taxi has done it. Because same way the Ansible framework for API will be used and 6 taxi protocols will be used. Or if it is less than 5 as a score, or the hunting team finds or figures out that, yeah, this is not good enough for being an IOC, it was more like a very low event, it was not having any potency to harm my infrastructure applications or my servers, then I might as well just ignore it, and that will go and sit inside the MIS reports. So this is how you will see again now a same process which has been written will be delivered by a platform of SIEM along with the SOAR. So you will write this for the SOAR. Now in SOAR, if you look at this particular workflow, you're not able to distinguish right now between a SQL injection or a phishing attack or an exfiltration of data or any other form of attack or a ransomware. So when we'll start bringing each one of those scenarios and start writing these rules multiple times, so this will become like a run book, and that run book will be deployed on a SOAR platform, because every time it is writing a IOC, maybe if it is a SQL injection, then that IOC might have to be written back into an IPS and into maybe possibly a database access management modules, access management tools, DAM tools. Okay. However, if it is a phishing attack, then the IOC might be written onto a DNS or might have to be written on your mail filters. So this way, the respective enforcing device might change. Hence, we have to write multiple orchestration / SOAR rules in which will collaborate, which will be collated together, and that collage of all these rules individually for solving my each of those use case scenarios, which I have given you 2 examples here, a SQL injection, for example, and maybe a phishing attack. A ransomware might be a third attack, and so on and so forth. Then within SQL injection, you might find that, okay, a core banking SQL injection is different from the SQL injection on the loan applications, because those 2 are written in a different frameworks. So you will see that you are writing on multiple rules in the playbook together, and this all will be constituted as a SOAR playbook, SOAR playbook. Yeah, folks, any questions?
Sir, like in Gen 3, we were talking that we have some shortcomings. Like we have multiple teams for different departments, like IT. Within IT, we have separate team for network, security, and all of that. Like for servers also, we have a separate team. So does this particular Gen 4 help us, like the Cyber Fusion, help us bring all of them together, or it's still a challenge?
No, see see what was happening. Good question. I mean, thank you very much for asking. First of all, see, please understand, we are not breaking the boundaries between the teams. Okay, But what was happening was that when my elevator pitch, for example, to such teams is when 4 people are sitting together from 4 representing different teams, and their entire objective is to do a security operations for the application, server, compute, and maybe the network which they have put in together. They will immediately switch off their mind the moment I will start from, oh, orchestration and automation is what we want to achieve. So what we have done is that instead of proposing that as an idea, while as opposed to this, if you go to a born in cloud company, which is a fintech company of today, they will have smaller teams. They may not have a political bureaucracies between them. They might like that idea. Yeah, this is good. Yeah, let's move on. So this was happening in the generation 3, that the elevator pitch or the starting point was not that great. Automation and orchestration was the objective, because it was a knee-jerk response from what was suggested that, boss, we are missing the action. So everybody started talking about action way back after 2015. But what people realized that in the action, it's only the orchestration and automation which is important. But that's not the piece of the final solution. It is a part of the entire solution. So we need a platform which should be able to handle a large scale problem of handling multiple diversity of the events, plus the human beings have a shortage of the skills. The attack vectors are becoming multi-pronged. So they need to put together into a platform where that platform is capable to be able to do orchestration and automation as one of the objectives or the end results. But let's not focus only on the end result and kill the bird in the beginning itself. So it's more of a strategy change, I would say. While when you change the strategy, maybe you change the execution as well. So since we have changed the strategy and an execution, that's why generation 3 was very short term. It moved to a generation 4, which is the current generation of cyber fusion centers. Did I answer your question?
Yes, sir.
Yeah. Any other? I'm okay to take one more question if anybody has that. Okay, so we'll meet tomorrow morning, and that time we will build the SOC right from scratch. Okay, and we will bring it from where it is in the current scenarios and taking it up to the situation of what we are readily available with today's solutions and the context of current times. Good luck.
Tomorrow what time, sir?
10:30.
10:30.
Yep.
Sir,
Okay.
I have another session coinciding with that.
So
at 11:30.
We'll do a recording. You can view that later.
Sure, sir.
Yeah? Okay. Thank you very much, folks.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.